Here's the key to paper quiz 7. And the first problem asks us to convert from logarithmic to exponential and from exponential back to logarithmic. The key finding here is to remember the ABC that we discussed in class. Log base A of B equals C is equivalent to A to the C equals B. That's a key observation. It's a good thing to know. And so in this case we have ln of 4 equals x. In this case the base is e. So we know that e to the x must equal 4. In this case the base is z, and so z to the 4 must equal 3. Now going the other direction, the base is 2, so log base 2 of 6 equals x. And here the base is y, so log base y of 4 equals 3. And finally the base is 3, so we have log base 3 of z equals 6. Now these are just short answer questions, and it's a good idea to have some visual cues. So for example, in this case we're asked some questions about log base 2 of x, and it's useful to have in your head or somewhere. You can graph it certainly, but I'll draw a picture, a generic picture. Y equals log base A of x for a greater than 1. They'll all look basically like that, going through 1, 0. And obviously they'll be stretched or shrunk vertically as the case as A changes. Now in our case certainly we have log base 2 of x, and its domain, you can see that's a set of x's, would be 0 to infinity, and its range would be all real numbers minus infinity to plus infinity. And you can see it's an increasing, it's an increasing function. It's an increasing function across its entire domain. And of course, if it's an increasing function across its domain, then it's a one-to-one function, although the opposite is not true. Okay, and here we're asked to give the inverse of it, and in each of these cases, the inverse will be 1, 0 goes to 0, 1. Will be an exponential function with the same base, and this is y equals a to the x for a greater than 1. And you see the domains and ranges have switched, and the inverse of this would be, let me just write it out, f inverse of x, we're given a space for it, would be f inverse of x is 2 to the x. And now we're asked about vertical or horizontal asymptotes. Well, again, remember what an asymptote is. It's a line so that the graph for which it's an asymptote, the graph gets arbitrarily close to that line as you travel away from the origin. For example, the y-axis is a vertical asymptote for this logarithm, because as we travel away from the origin, we see the distance between the curve and the line goes to 0. The x-axis, which has the equation y equals 0, is a horizontal asymptote for this graph. As we travel away from the origin, the distance between the two goes to 0. And again, remember, you can cross an asymptote, and the classic case for that is, say, a pendulum, in which this represents rest, and you can have a graph which has this horizontal asymptote, and it crosses it infinitely often. It's like a pendulum swinging back and forth. Now, vertical asymptotes, okay, it's difficult for a function to cross a vertical asymptote because you have the problem with the vertical line test. Oblique asymptotes you can also cross infinitely often, and again, similar case would be something like this. Okay, so the idea here is we want to describe what the asymptote of ln x plus 2 is? Well, one way to do this is to remember the graph of ln x, which again looks like every other log. Okay. And you go through 1, 0, and again the base here is e, which is around 2.7. Okay, so it should look like our log base 2 graph. In any case, we don't have ln x, we have ln of x plus 2, and if you remember transformations, we know that that's been moved to the left by 2 units. So everything in this picture, including the vertical asymptote for ln x, which by the way is not part of the graph, but it's part of its position or shape, so that will be moved left 2 units also. So what was the y-axis now becomes the line over here at -2, and what was 1, 0 now becomes -1, 0, and so the graph of ln of x plus 2 becomes this. And we have then a vertical asymptote. Now how do we describe that? We could draw it. It's fairly clear here from this picture that it's the vertical line at x equals -2, and in fact its equation is x equals -2. That is in fact the vertical asymptote. It's a line, and how do we describe a line? We could give all the points on it, which is kind of boring. We could draw it, and if your graph is accurate enough, that would suffice. Or you can give its equation or some other defining property, and the equation is x equals -2 in this case. So our graph has a vertical asymptote of x equals -2. And you could write the vertical line at x equals -2, or going through -2, 0, whatever. Now e is a change of base formula. We're asked to write log base 2 of 6 in terms of base 3, and again we can write it in terms of anything we want. We could write it in terms of base 10. We could write it in terms of base e. We could write it in terms of base 3. And this is the one we wanted here. Any one of those is equal to the others, and for calculators purposes we probably would use one of these.